Okay, Assalamualaikum warahmatullahi wabarakatuh. Hi guys, good morning. So today topic is concurrent engineering. So we already learned this one. I hope you already understand because this is a learning outcome for this topic. Understand and apply the concept of concurrent engineering as a manufacturing strategy. So I hope you also understand the importance of concurrent as a manufacturing strategies. Understand the concept of quality function deployment, QFD, and then you also can apply house of quality as a manufacturing strategy in production environment. So what is concurrent engineering? So concurrent engineering is a strategy where all the tasks involved in the production development are done in parallel with collaboration with all individual inside the department or company. So which is consists with customer research, designers, marketing, accounting, engineering, and all those can be give the input to the improvement development. So they will be concurrently done, parallelly done by involving all these members. So from this chart, you can see the linear process for the commercial design process for the development of product. So as we learned before, we have a product design and process design. So here also you have the a chart for linear process, which is idea generation, and then we go for FS, feasibility studies, and preliminary design. After that, you can involve with the final design and process plan before you do before the product launch implemented. So then we go one by one for explanation for this one. So I want to turn on my marker here. So wait, I want to find out how to. So never mind, I cannot find out how to use the marker this time. So but I will point out by mouse here. So for idea generation, we have this one we already learned how to bring out the idea. We have some technique. We already learned the brainstorming techniques, reverse brainstorming. So from there, we also have perceptual mapping, benchmarking, reverse engineering to get the idea. So this idea normally in concurrent we involve for all from the competitor, supplier, R&D, customer, from the marketing side to get the input from our regarding our product or service to build the new concept for that product or service what we will offer to customer during development. So this idea is very important. So the first is idea generation. Then we can use this method, this one perceptual mapping. For example, we do this product for the food. For example, we made the mapping low nutrition, high nutrition. That is the first line, and the second line is good taste and bad taste. We make a cross line here. So from here we map our product in the market. For example, Cocoa Pops. We have a good low nutrition, but somehow they have a good taste. And then we put Rice Krispies here, low nutrition and bad taste. So and Some product they have higher nutrition but with the bad taste. So this is the mapping, perceptual mapping. We can compare the customer perception for the available product, and then we can see the gap. So here, of course, this section, good taste and high nutrition is the best. But we should target our product to this particular area. But we can do the mapping, and then we can see the actual one, and then we can set our own target from here. So benchmarking is very good because we can see the best product available in the market, and then based from there we can do benchmark their performance, their specification, and then we can do benchmarking for our new specification for our new products. So we also can do a reverse engineering. So we can see for example some product we can take from the market, and then we can dismantle and then inspect the component inside, what they did for their product. So we can do a benchmarking by reverse engineering. So we can select the features to our new product to incorporate into our new product. But some product they very they protect their product to be copy or to be seen by competitor. For example, you can see PlayStation in the one time video game. Sony developed a PlayStation. So they have some method they use in the PlayStation. They after the competitor want to dismantle, to do a reverse engineering for copying their product. So when they open the cover for the PlayStation, the system will be they have a protecting system. So the IC, the everything inside that will detect that one. They stop everything. They have some key or some function to dismantle their function before the competitor to have to see what inside the PlayStation inside. So that's why they can protect. They manage to develop by their version, so nobody can compete with them. So if the competitor want to do similar with their product, they just can see from outside. But inside, even though they dismantle, they cannot see what inside. So that is how they protect competitor to copy their product through reverse engineering. But here I want to explain to show you that is the method what we have from benchmarking, reverse engineering to develop the new product using this technique or method. And then after that we conduct FS, feasibility studies, to do a performance, to see the performance, and then to finalize the specification, performance specification. The demand for the product, we can here we need to see the demand for the proposed product, cost of developing and producing the product. So does a company have a manufacturing capability to do it? So here we can see the available facility what we have, and then what else we need to buy, and then is it we have a skilled personnel to do this one or not. So in this feasibility study we do with analysis, we conduct the analysis, and then we come out with some report. So from this report, the management or top level management will decide either we need to carry out the next level or not. So the next level is a preliminary design. So after they approve the FS, and the management will instruct the design section, which is to do to form the design, to form the product design, production design, and to see the functional design. So this process will be one cycle. To see after they form the design, they do a production design and the functional design, and again to see the form design. So the reversing and testing prototype, so they will conduct here, and then to somehow after they have a production the product, they do a production design. You see in the previous slide, after we have developed a product in terms of product design, we did a process design for manufacturing specification. So we need to have a SOP how to do it, how to produce the product based on manufacturing specification. And then functional design. So functional design is related to product itself. After they have developed some product, of course the product specification and then the functionality, the features, how to use the product. So they have include inside design specification. So all this one come out after finish the preliminary design, and then they will do a pilot run and final test in the final design and process plan. So actually in the pilot, before this one, they do a evaluation test for the prototype. After they produce prototype, they do evaluation and analysis on that, and then they finalize the specification, the design, and then in this time they do a pilot run to test to get the final test result. And then after they agree all this specification, design, so they will do a mass production. They do a product launching and then do a mass production. So the product is marketed to buying public. They market and they introduce to the market. The market will grow and then maturity and then decline. That is the cycle of the product. So this, I believe that you already learned that one. So the cycle of the product after product launch. So this is all process development for new product using in this slide using the latest or concurrent engineering techniques. And then for summarize, we have a traditional process, linear process to develop the product. Actually, in the traditional conventional way, we did the development after we receive from the customer. Actually, customer complain or give idea, give concept, and then give pass the information. We pass all those information for production product concept to the marketing personnel. So customer they discuss and then they pass it in the marketing personnel to do some summaries for the product concept, and then they did some performance specification and pass over to the design. Normally for market personnel involve engineering guys for that section. So normally they have the term for the sales engineer. So actually the engineer become salesman because they want to give more information regarding their product to the customer, and then they get some feedback or information from that customer and then pass over and then they do the compilation for the request and then do a performance specification because they already engineer, so they know how to do it, and then they pass over to the design or manufacturing engineering sites to do a design specification details, and then after that they will pass over to the production site personnel. In the traditional process, actually when they pass over to the production personnel, so because the production side never involved inside the design, normally they will face some problem in terms of fabricating or process, because the production guys normally they see the drawing, they see the specification, they try to translate that drawing to the actual one. So they see, and then they based on that the machine, the tool what that they have in the line, in the production line. So the tools, the machine, the equipment normally will reflect to the product manufacturer for product to produce the product. So that's why for the concurrent engineering, they make a team collaboration. They involve all, even from the manufacturing side, from customer customer marketing, even competitor. They take the information from competitor, they put inside this meeting for concurrent meeting for design. We call it design team to do some development for new product. So from there, they will know earlier information from the production, for example, how to do it, what they have inside the line, what customer need from the customer or sales engineer side, and then from design and manufacturing R&D person, they know how to design because they already make a clear picture or clear information from the floor, and then from the outside, from the inside capability what they have, so they can do more better development within concurrent engineering method. So the importance of concurrent engineering is the pace of market change has increased, so they need to do this one very fast. So when we involve all inside, so they can make a job become more speedy. So companies must keep pace with changing market. So that's why they need to do keep the pace to catch up with the new trend, new development. And decision made sooner rather than later. So they not do a fast decision, reduce, eliminate repetition of tasks. So within the meeting design team, they can reduce or eliminate the redundancy of the task, and then reduce waste, and then review or design, of course, after they pass the drawing to the production section. For example, if the production section need to revise the drawing because there's some mistake, so they will have need engineering department to do. So they have consume the time of revoke or redo for that one. So we can reduce reduce the waste, can make a process quicker, and then can make more efficiency for the design, for quality of the product what we develop, and then can maximize the company profit. To make decision concurrently, team knows the design goal and objective. Normally when we do a group, we form the group design section, we will brief with the design goal and objective to all team member, and then team member will arrange, we can see and then they are aware the interrelation between all the aspect and design process, and then communication, superior communication between all section of the company, because they involve all team member from different department. And then normally the method what we use is quality function deployment, QFD. So what is QFD? QFD is a collection of matrices that converts the need of the customer. So the collection metric, and then convert the need of customer into technical specification. So we need to convert to the technical specification in term of design specification. So all stage of the design and manufacturing process, we need to convert to the all stage of design and manufacturing process. And then the most popular one is the house of quality. From the quality function deployment QFD, we have house of quality. So I believe this one we already have a tutorial session for this one, and then I already briefed on the previous class and then previous tutorial session we already did the example. So this house of quality is very important because house consists everything. They consist the roof, top, living, the kitchens, the parking area. So they have involve the house structure. So you can see here from the house of quality, we have one customer requirement. Number two is a competitor product evaluation. From the competitor, we do evaluation between our product and market and competitors, and then we can see the engineering characteristic, and then we make relation between the engineering characteristic what we have there, and then after that we do a target for our product. That is number 6. So we go one by one for this one. So this is example. So example, we want to develop water pond alarm. So from this one, we need to identify customer requirement and then do a prioritize them for the scaling to doing the voltage. So we do a weighting for this one. So we have attribute here for the water pond alarm is sensitive to water, number 1, water level, number 1, durable, number 2, makes a lot noise because it's alarm. So inexpensive, we need to produce the cheaper one, and then small, and then look good. This is attribute for the water pond alarm. We try to design. So we do a market survey, we do to see to find the survey, and then to see the weightage, and then we make the ranking from there. So from here we can see inexpensive and then sensitive to water level is most highest weightage. So there is most priority for this product. So we need to design or to develop according to this one. We need to develop the more cheaper product and sensitive to the waters. So others is like look good, small, durable, loud nice, is a less priority than from the expensive than sensitive one. So this is total 100. So then we make a comparison between product and then our target. So we make a comparison product in the market, the competitor one with the target product. So for example here, so the highest one sensitive to the water 25. So we see in the market the level we put 1 to 5, so we can also make percentage also. So in this case we just put the level 1 to 3, 4 and 5. So for the A company inside the market, they at the level 3, but for us we just because this is priority 25 higher in the market survey, we want to focus this one, so we put in our target is at level 4. So for the inexpensive, we need to develop more cheaper product because this is highest demand from the market. So we have at the level 3 is a B company, B product and A product. So we target ours is a number 5 more cheaper from B and A. So this is how we make a comparison, and then we put our target. So for the made a lot noise, so there is less priority, just 10 here for the weightage. So now company A is we're at the level 4, but company B at level 2. So we target in between, not so high but not so low, but in the middle. So because when we win on this one, sensitive to the water, and then cost more cheaper product in term of cost, so of course this one become less priority based on our survey. So we can concentrate on the middle level. If we concentrate more on this one, maybe we cannot sell our product in the cheaper product, because we need to focus to use the good sensor in the loud noise, and then whatever is, we need to give a better or concentration on this one, so the cost become higher. Similar goes to this one, small. So we less priority, but for look good is higher than that one. So this one maybe we think this one related, because we want to have a compact product, look small, look good. So we want to have something here. So we just put at the level 4 for the small one, and then look good, we need to compromise in terms of this one, because we want to make more cheaper product. So even though the company 4 is better, so but the price for company 4 is quite, company A is quite expensive, look good, expensive, make a lot noise. So this one is very good, but we need to consider from the survey, we need to consider that the price is become priority, and then the sensitivity also become priority. So we make this one, and then we make a judgment from this comparison, and then we do identify engineering characteristic for each attribute what we have. We try to relate with the engineering characteristic. For example, complexity of circuit. For example, this one, complexity of circuit, they always related to the sensitivity or sensor or circuit design for this one. And then so we use this one, complexity of circuit. Even though they will related also to the make a lot noise. Maybe the circuit become complex when we make a loud noise, for example. And then energy efficiency also one of the engineering characteristic we need consider, because when we use the highest noise, and then the sensitive to the water, we use the good sensor here, so they will involve with the energy efficiency. And then material for casing, we also consider as an engineering characteristic, because when we make a durable product, a small look goods, we need to consider the material what we use, the casing what we use, because all item like sensor, the circuit board, so all inside the casing. So cost of the sensor, so of course they have sensitive to the water, they have will use the good sensor to be sensitive, so that one will be reflect to the cost. And then also the noise also, they will reflect with the sensor cost. So we do when we identify, we can do the interrelationship between customer requirement and the engineering characteristic. So we have legend here. For positive correlation, we put plus, strong positive correlation, double plus, and then none, and then negative correlation, and then double negative for the strong negative correlation. Even though we can also make the marking or percentage for the positive, a strong negative, and a strong negative, but here they use a plus and a double plus. So we mapping the relationship. You can see here for sensitive to the water, for example, they have very related to the strongly positive correlation with the circuit and the cost of the sensor, but positive correlation with the energy efficiency. There is for the sensitive to the water attribute. But for durable, there positive correlation with the material casing. We need the good material casing for more durable. But for the inexpensive, to make cheaper product, they have inverse. They have this one, negative, strongly negative correlation with the complexity of circuit. Double, this one double negative, strongly negative. So we need to have more simple circuit for cheaper cost, cheaper product to sell. And then material casing plus. So this one, of course, we use a good casing. They have positive correlation because for cost will reflect to the casing. So this one I already explained just now. So then we identified the correlation between engineering characteristic. We have already this engineering characteristic, complexity of the circuit, energy efficiency, material of casing, cost of sensor. So we developed the correlation between this one. So how to do this one? We see the complexity of the circuit. From here, we just draw the line, and then we see this minus here. So they will related with this one, if energy efficiency. So complex circuit minus here correlation. Complex circuit more part. Complex circuit we use more parts. They will could reduce energy efficiency. So energy efficiency here, complex part with negative correlation with the energy efficiency. But for the complex circuit with the cost of sensor, more complex will use the costly sensor plus here. Increased complexity of the circuit, require more cost for sensor. So you can see a plus here. For this one, cost of sensor, and this one, energy efficiency. So a good quality of sensor here could improve energy efficiency. That's why plus. Energy efficiency will improve with the good quality of the sensor. So we finally identify target for our new product. We have an engineering characteristic here: complexity of circuit, energy efficiency, material casing, and cost of sensor. So we have a objective measure. We made also comparison. Some house of quality, we can also put the competitors inside our target new product to see how the competitor and how about our new design target. So we can do strictly, we can see the comparison straightly here. For the complexity of circuit, we can see our target is 9 number of part, because when we see company A, product A using 25 and then B 30 part, so there is more complex. So we target 9 to make more simple. So because this one will be reduce the price, the cost, because they are strongly negative correlation for parts or complexity with the cost. And then for energy efficiency, we can see here for others company, because we put for energy in between A and B, so we just put company B is 95, company A 120 battery life in hour. So we just target for our design is 100, but we still target to manage to achieve similar with the company A. That is our target. We also have target line here. And then for price, you can see here. So we strongly focus on the price. So we can see the price for the A company is 45, company B is 35. So our design, we focus the 20, but target not more than 30. So that's why when we can sell not more than 30, we can get more profit. But in design, we still target 20 for the cost of the sensor. So this is a normal one for the auxiliary power unit product plan matrix for the auxiliary power unit. So this one we already discussed in the previous class and tutorial, so I not to explain anymore this one. So this is the example. So I hope you can do a tutorial for this one, and then do a self revision by using this video, and then if you have any question you can ask me at any time. Thank you. Bye.